Hi, Steve again with SSI. Welcome to the show. Today I want to talk to you about knurling. Now this is a particularly difficult thing to do if you're a novice machinist. So for all of you older guys that already know how to do this, it may not be the episode for you. I'm going to try to go into a little bit of detail about it so it'll make it easier for the novice to have a better shot of actually getting this done and making it look pretty and correct. I'm not going to talk about diametral pitch knurls because most of those are for sizes of 32nds or 64ths, and you can usually find a catalog that will guide you into the direction of the sizes they fit, whether they be fine, medium, or coarse. I'm going to talk in this episode mainly about circular pitch knurls, and the knurls that are being used are going to be the ones that are used for small lathes or small machines that are 14 inches or less in swing. I sat down many years ago and figured out circular pitch knurling and how I can use it on a small machine. So I'm going to go over circular pitch, how to figure it out. If you have a knurl that you don't know what the pitch is, show you how to find it, and then I'll demonstrate it on a small project that I have in mind and show you the project at the end. I will go over some of the types of knurls that are common usage on these smaller machines and show you the one that I use most and usually have the best results with. Let's talk about types of knurls in general. This is a common knurl and is usually found whenever you get a 5-piece quick change tool post. It has a couple of knurl wheels on it. It's also a bump type knurl. Whenever the stock is in the machine, like such, you use the cross slide to push the knurl into the work. Well, the issue with a lot of bump style knurl wheels is they put an excessive amount of force on the brass nut that is inside the cross slide. The harder you push into the workpiece, the more damage you could cause to the brass nut. Brass is not that tough and can easily strip out. So this style of knurl puts a lot of stress where stress is not needed. Now to center one of these, you always get it as close to center of this line between these two pins as you can. Then you can adjust the up and down height of the knurl wheels until they basically both touch the workpiece. So they basically both touch the workpiece at the same time. That's what you're looking for whenever you get one of these set up. Still not my first choice. It's just better than a lot of things. This is a swivel head style knurl. To center one of these up, you use the center line of this piece, the piece that is held into the tool post. It's the same thing you're looking for, both wheels basically touching at the same time. The nice thing about the swivel head is if you get it really close, the swivel motion of this head will compensate. So that helps a little bit. It still puts a lot of pressure onto the cross slide nut, which is something else that you don't want, but is very common on smaller machines. Then there's the single wheel on a particular tool holder. This one's been used a few times. I don't like it either because it is also a bump type, and the center line of this is the same as the other, right along the shaft, pushes up against the work. So this is also a bump style knurl. Not very good. None of them are. I don't like them on smaller machines because smaller machines can't handle that type of stress. Then there's another one that is used is a scissor knurl. Now a scissor knurl clamps around the workpiece. So all of the knurling pressure is handled with the drawbar of the scissor knurl, or clamp style knurl. Some of them that actually look like a pair of scissors, they come over both directions just like a pair of scissors would, and they're called scissor knurls. This is more of a clamp style knurl, even though they can be named either way. Clamp style knurls are pretty robust, pretty tough, and it takes all of the stress out of the cross slide nut, which is what you're looking for on smaller machines. This one happens to be a shop-made style knurl, and this is the one I used most often in my shop. So let's talk about knurl wheels in general. This is a pretty broad selection here, but we've always talked about coarse, medium, and fine. And I'll add some slides, still pictures in here, so you can see more detail of what these are. Fine knurls, like this one, really close together, and I don't know if you can see it in the camera, but like this one here, this is a coarse knurl. You can see the lines are all 45-degree angle. This is a diamond style cut. Same with this. This is also a diamond style. So the pattern it leaves behind is what you'd usually find on ratchets and things of that nature that have a real nice pretty diamond knurl. So you have a left and a right to make that pattern. Now this one is a straight line knurl, so it's just straight cuts all the way across it. You could almost call it a spline even, but it's not a spline, it's a knurl. So you can always find different wheels for knurls. There's different wheels, there's different grades, there's different types, what they're good for, what they're not good for. They're usually marked on the side of the wheel of what they are, of what pitch they are, and pitch being the circular pitch of the knurl wheel itself, which basically gives you the how many lines per inch or how many knurls per inch there is on the particular knurl wheel. You can see this one was on a 5-piece quick change tool set. You can see how cheap the material is. It is all rusty and not in very good shape. It didn't do a very good job anyway. It's not very hard steel, not like one like this. This one's pretty hard, is also dished on both sides for clearance, so it helps evacuate swarf and things of that nature. This one not so much, but it is a very hard, good quality knurl. So you can always find your own knurl wheels and build your own knurl mechanism, either a clamp or a scissor type, like I did on the shop-made one here. Things never let me down. It's always been a very good quality piece. So we talked about circular pitch, and we need to figure out what our circular pitch is on a knurl. The reason we need to figure that out is because of the tracking that is on the knurl itself. We don't want the knurl to track over itself. We want it to track properly, which means each time a knurl lands on a particular workpiece, it will land there on one side and it will land there again when it comes all the way around. That's tracking. You want it to track properly, or the knurl itself will suffer. Let me back up for just 1 second and talk about a little bit about the medium, fine, and coarse knurl wheels. Okay, the fine wheel, if you put it on a small part, or a small diameter part, will look more coarse than what it is on the knurl itself. if you use a coarse knurl on a large diameter part, it will look more fine on that particular diameter of part, depending how large it is. So there is a little bit of guesstimation, you could call it, or trial and error that you would have to do to find the style of knurl wheel that you would want. Now, that can all be found in books and things of that nature, but a lot of the time it's just one of those deals that you have to do a few parts to kind of figure it out as you go along, and the more practice you have, the better you'll get at knurling. So let's talk about circular pitch knurls. Let's figure out the pitch of a particular knurl wheel, and there'll be just a few easy things here that you're going to need. This is carbon paper, or carbon transfer paper. It has carbon on one side, nothing on the other. This is a piece of construction paper, so we can use this piece of construction paper to figure out our circular pitch on our knurl. So we lay the construction paper down because it's nice and soft. We'll put our transfer paper down, transfer side down toward the construction paper. Then we can just use a regular piece of copy paper on top. Now I want to find out what the circular pitch of this particular knurl wheel is. So how do we achieve that? Is we can lay our one knurl wheel on our paper, make sure that it's laying flat, and we push it across. I think I got that exactly what I want. It's pretty close. Let me do it again. Takes a little bit of practice to do this. So what we have now is a transference of our knurl wheel onto our construction paper. The reason that we need to do that is because knurl wheels are measured in teeth per inch. So we have however many teeth that are laid down in 1 inch of travel. You can't measure from 1 inch here down or 1 inch travel here and take account, because this is what they call transverse pitch. Transverse pitch is actually on the wheel itself in 1 inch, and usually you can find a chart that will transpose transverse pitch to circular pitch. I don't have that chart available, so I need to do it this way. Now, the way you have to do this you lay a ruler down in line with the angle of each particular mark, and you draw it out, and you carry that on as far as you can, and when you're done you would measure from here to the 1 inch mark each and every line. Now, already done that on a separate sheet of paper, one like this. This has all my measurements on it. So when this is all done, these are all the little lines that come off of that, and it gives us a number count of 26. This is the 1 inch area. This is where the 1 inch area stopped, was right here. So 1 inch from here to here, counted all the lines in between, that's 26 lines. And here, this is the version of the transverse pitch, which is measured from the top line, top corner, down to the straight line. So at the bottom it was 21, then there was a half line left, so it's 21.5. So 21.5 in transverse pitch equals 26 of circular pitch. So we use these numbers to find out how many lines will be wrapped around the workpiece when it's all said and done. And we always have to have that come into a even number. So what diameter we're going to use it on is something that we already have in mind as our workpiece. Now if you're making a hammer handle or a ratchet handle or anything of that nature, or some kind of handle to get a grip on, you've got a pretty good idea about how big you want to make it. So we start off with a pretend number. Now on the project that I want to build, I wanted to make it 1.5 inches in diameter. That was my rough guesstimate. It doesn't have to be 1.5 inches in diameter, but I would like it to be 1.5 inches in diameter, or very close to it. So that's the number I'm shooting for. Now, to find our numbers, we have a couple of equations. Now our equation states that the number of teeth is equal to 3.14159, or pi, times diameter divided by pitch. Well, the pitch is 26 teeth per inch, right? Okay, that is just like a nut or a bolt, as in linear pitch, 1 divided by the number of teeth per inch. So as in a 1/2 inch 13 bolt has a particular linear pitch of, I think it's around 76 thousandths 9/10 per inch, or from tooth to tooth. This is the same way. So we have 1 divided by 26 gives us a circular pitch of 38 thousandths 4/10. So we can plug those numbers into our formula here. So we have pi times diameter, or diameter is what I said before, is 1.5 inches, divided by the circular pitch of our knurl wheel, which is 38 thousandths 4/10. And that will give us a number of teeth of 122.7 teeth around that 1.5 inch diameter part. Remember what I said a while ago, it has to be an even number. So our even number that we're looking for, we have to round it up or round this down to decide what we're going to use. Do we want to do 122 teeth around that diameter part, or do we want to do 123 teeth around that diameter of part? Well, that's where another formula comes into play. The diameter of the part now would be equal to the pitch times number of teeth divided by pi. So we can take our pitch of 38 thousandths 4/10, multiply it against the number of teeth that we want on our part. So I'm going to want 122 teeth, an equal number. Nice round equal number. Divide that by pi, and that gives us the diameter of 1 inch 491 thousandths 2/10. So that's what I have to turn the part to get an equal number of teeth all the way around my part. So those teeth will land on top of each other as it goes around the workpiece. That particular thing is called tracking. You want the knurl to track properly around the part so the teeth do not land off of each other. You want them to land in the exact same spot all the way around. Now there is some skepticism there when it comes to this type of thing, that okay, we know if we turn the part to 1 inch 491 thousandths 2/10, that's going to track properly at that diameter. Well, now you're pushing together on those knurl wheels, or pushing against it with your bump knurl, so that diameter will get smaller the harder you push. That is true. But apparently it's okay because it works. As material is pushed down, the other material is pushed up, so it kind of equals it out. The problem that a lot of novice machinists run into when they do this type of thing is they push too hard too fast, the speed of the spindle is too fast, and it takes its toll on the part and starts to tear the knurl, and it gets off of track. Because now you have swarf that is coming in and landing in the way of the knurl wheel and is getting pushed more and more, or the tops of the crest of the diamonds are pushed down because the swarf is on top of it, where you've pushed too hard and over knurled it, where the top of the peak is crushed, creating more swarf, more problems, more things happen, then you start to tear the knurl apart. This is not something that you can go into quickly. You have to take your time, you have to be patient for the product to come out properly. And of course you have to use lubricants. Remember, knurls do not cut. They push material. They move material down one side and up the other to make the knurl happen. That's why a knurl is larger when it's finished than the apparent material that it is when it starts at. So our 1-inch 491 2/10 may wind up to average out at 1.5 inches at its knurled status. The tops of the peaks may be this large. It ranges from anywhere from 15 to 25% growth depending on the type of knurl, how hard it is, what type of material it is, a lot of different factors. Where there's more trial and error there is charts and different things that can help you find specific measurements. If you're trying to use a knurl to be in a pressed hole, which is very common, works very well. Knurls are used a lot of the time in injection molded plastic. They knurl the part, put it in there, a steel part, put it inside the mold, inject it, and the plastic forms around the knurl and gives it a nice tight grip until the plastic fails. But if you're pressing a steel shaft into an aluminum part and you want to put a little bit of a knurl on it to tighten up that press, you can always use this type of knurling system to do it. You just have to be you have to do a little trial and error to get all your numbers correct. But for what we're going to do with my project, it's going to be 1-inch 491 thousandths and 2/10 is what I'm looking for as my finished diameter before I start knurling.